All right, guys, welcome back. This is going to be the 8.4 instructional video, or at least the first part of it. Here we're going to introduce the ideas in 8.4. In a subsequent video, we'll finish going over the rest of the examples. But here in this one, I just want to introduce the idea of 8.4. But before we get to the definition, I really want to kind of show you the idea behind 8.4 and where 8.4 comes from. So what I want you to do is on your notes, I want you to solve the following problems, okay? Or rather, not solve, but simplify the following. You should know how to do this from 8.3. If you don't, I'd encourage you to go back and watch 8.3 instructional video. So hopefully you've solved these, and hopefully what you came up with is 3 to the 12, right? We have like bases multiplied together. So what we do, our shortcut when working with exponents and algebraic expressions involving exponents, when we have like bases multiplied together, we add the exponents. With what we have down here, you hopefully got 2 to the 28th power. Again, 4 like bases multiplied together, so we add the exponents, and we end up with 2 to the 28th power. Again, if this is new, please go back and check out the 8.3 instructional video. Okay? Now, what I want to think about is, is there a different way we could write these expressions? Okay? Is there a different way we could write these? Okay? And maybe you're sitting there going, I don't really know how we would rewrite these, but maybe this will help jog your memory. How could I rewrite x times x times x? Well, hopefully what comes to your brain is, wait a minute, that is x to the 3rd power. Okay? The idea of exponents, repeated multiplication of the same thing. We write that in math as a shorthand by writing an exponent. Okay? X times x times x is x to the 3rd. We have 3 x's multiplied together. So how does that apply what I'm talking about here in rewriting the left sides of these equations? Well, 3 to the 6th times 3 to the 6th, what is that? Well, it's 3 to the 6th being multiplied 2 times. We have a repeated multiplication of the 3 to the 6th. So shorthand, I could rewrite the left side of this blue equation as 3 to the 6th squared. Consequently, I could also rewrite the left side of the red equation as 2 to the 7th to the 4th power. What, right? I have 4 2 to the 7ths multiplied together. Now let's examine these two truths, and I think you're going to see the main idea of 8.4 pop out of this. If by our 8.3 knowledge, we know that 3 to the 6th times 3 to the 6th is 3 to the 12th, and by our knowledge of what exponents are, we can rewrite 3 to the 6th times 3 to the 6th as 3 to the 6th squared, then we should know that this should be 3 to the 12th. Okay, the logic I'm using here is if these two things are equal, right, these two things are equal, and these two things are equal, right, then these two things must also be equal. Is kind of the logic I'm using here, right? We know 3 to the 6th times 3 to the 6th is 3 to the 6th squared. And we know 3 to the 6th times 3 to the 6th is 3 to the 12th. Therefore, 3 to the 6th squared is 3 to the 12th. By that same logic, looking up here, we know that 2 to the 7th times 2 to the 7th times 2 to the 7th times 2 to the 7th is the same thing as 2 to the 7th to the 4th. And we know that 2 to the 7th times 2 to the 7th times 2 to the 7th times 2 to the 7th is 2 to the 28th. Therefore, 2 to the 7th to the 4th is also 2 to the 28th. Now, if we look closer here, okay, again, we've just been following some logic based on our understanding of exponents in 8.3. If we just look at what we've observed here, right, we've drawn the conclusion that 3 to the 6th squared is 3 to the 12th, which we know to be true from our logic above. And 2 to the 7th to the 4th is 2 to the 28th, again from our logic above. What conclusion can we draw from looking at these? Well, there's a shortcut. Anytime I have a situation like I do on the left, an expression like I do on the left, I don't want to have to write it out, right? I don't want to have to take 3 to the 6th and write it out as 3 to the 6th times 3 to the 6th and then use my 8.3 rule to get 3 to the 12th. No, I want to be able to jump straight from 3 to the 6th squared to 3 to the 12th. How can I do that? Well, you'll notice if you multiply the exponents, it turns out to be the exponent of your simplified version, right? 3 to the 6th squared, if I do 6 times 2, I get 3 to the 12th. If I have 2 to the 7th to the 4th, I get 2 to the 28th, right? Let's look at one more example to make sure the pattern still exists. 5 squared cubed. We know that 5 squared cubed is 5 squared times 5 squared times 5 squared. And by our logic of 8.3, this should be 5 to the 6th. And lo and behold, 2 times 3 is 6. So by some intuition in our knowledge of 8.3, the multiplication property of exponents, and just understanding exponents in general, we can draw the following conclusion. If you have a power raised to another power, an exponent to another exponent, you will multiply the exponents to simplify your algebraic expression. In visual terms, if I have some number a to the m power, and then that quantity, a to the m, is to the n power, this can be simplified to be a to the m times n. A to the m times n. Okay? A to the m times n. Now, for this, in order to be true, we need a to not be 0. Okay? But in general, if you have a power raised to another power, you will multiply the exponents. So let's look at a few examples together. Let's look at a few examples. And again, we'll go over more in-depth examples in the second part of this video. But I just want to conclude this video with some initial examples. We've seen some integer-based examples. Now I want to move to algebraic expressions. And I would encourage you to try and solve these on your own, or rather simplify these on your own, right? We can't solve them because we don't have variable values. So let's simplify these. Give those a shot on your own. Then check your work with mine. So hopefully you've given it a shot. The one on the left, we'll work our way left to right, is pretty straightforward. Okay, apply my new rule. When I have an algebraic expression with an exponent to another exponent, a power to a power scenario, I simply multiply the exponents, and this will be my simplified version of the algebraic expression. Okay, x to the third to the 6th power will be x to the 18th. Again, if you wanted to write this out to check your work, you could, right? You would have 6 x to the thirds multiplied together. If you then wrote out each x to the third, you would find in total you have 18 x's multiplied together. Okay, I'm not going to write that out for the sake of time, but again, if you want to try that on your own, you can. Moving over to my middle problem, again, I have a power to a power scenario, so I multiply the exponents together. I get a to the negative 28th. But I am not going to stop there, okay? We have learned how to simplify negative exponents, and when I'm simplifying algebraic expressions, I don't want to do half the work. I want to simplify them as much as possible. So a to the negative 28th can be rewritten as 1 over a to the 28th. If that is foreign to you, again, I would encourage you to check out the 8.1 videos. But here we end up with 1 over a to the 28th. Our final example, probably our most complex, and I think in order to get this one right, we need to understand what's happening. What we have here is c to the 5th being multiplied by c to the 3rd to the negative 2nd power. And at this point, and you're going to find as you get into more complex algebraic expressions involving exponents, you need to understand order of operations. It is imperative you understand order of operations. When we think about order of operations, maybe you learn the acronym PEMDAS or GEMS, depending on what you were taught. We know that exponents need to come before multiplication. So before I work with the c to the fifth and the multiplication, I need to handle my exponents. C to the third is being taken to the negative second power. So the c to the fifth will kind of just come along for the ride for now. And I'll do my power to a power, and I will end up with c to the negative sixth. Now I can handle my multiplication, c to the fifth times c to the negative 6. This goes back to 8.3. And we have c to the fifth times c to the negative 6, like bases multiplied together. We add the exponents, giving us c to the negative 1. And then we apply our 8.1 knowledge and simplify our negative exponent to be 1 over c. And really, I would hone in on this example because this is where you're going to find our study of exponent properties is going. You see, we're not just going to have individual rules in complicated algebraic expressions that we're trying to simplify. Rather, you're going to have many rules present, and you need to use each one appropriately. But again, the summary of this lesson, the new idea that we've seen here, is that when you have a power raised to another power, and we logic through why that rule is what it is earlier, when you have a power raised to another power, simply multiply the exponents. Guys, I appreciate you watching. Part 2 with more complex examples will be on its way.